Hi, everyone, and thank you for being here today. I'm excited to introduce you to our Platoon DevOps capstone project, BONSAI. Here's a quick overview of what we will be covering today as we walk you through our project. We'll start with a brief introduction, who we are, the inspiration behind BONSAI, and the core features of our full-stack e-commerce platform. Then, we'll walk you through a high-level overview of our architecture. Next, we'll explore the DevOps lifecycle, from containerization and infrastructure as code to CI/CD pipelines, and how we moved from local development with Minikube to cloud deployment on EKS. This section focuses on how we made our system secure, scalable, and stable. And in conclusion, we'll wrap up with lessons learned and key takeaways. Team Bonsai consists of myself, Mikhail Waddell, Aisa Barbosa, and Damon Gilden. Let me introduce you to our fully deployed e-commerce platform dedicated to the art and beauty of bonsai, which you can access right now at mwbonsai.com. This application was developed by myself and fellow teammates during CodePlatoon's full stack immersive program. Our vision was to create a space for bonsai lovers to purchase plants and accessories, read and write blog posts, chat with like-minded individuals, and discover local plant nurseries all in one place. It's a platform that blends the essence of nature with clean, minimalist design to deliver a serene, peaceful, and intuitive experience. The homepage welcomes users with soft gradients and an elegant layout, enhanced with smooth CSS transitions, subtle animations, and paginated content that guide the eye and create a polished, immersive feel. From there, users can explore a curated list of products, add items to their cart, read reviews to help guide their choices. Now that you've seen the desktop experience, let's take a look at how that same journey is beautifully translated to the mobile view. While a desktop experience emphasized elegance and clarity, we knew this was just as important to create a rich, responsive mobile experience. That's exactly what we built. You can scan the QR code on the slide to instantly access the mobile version of MW Bonsai. From the mobile homepage, users can log into their profile and unlock personalized features, including daily Zen quotes, local weather updates, and access to interactive 3D bonsai models. With Google Maps integration, users can explore nearby bonsai nurseries based on their location. And thanks to augmented reality feature, they can view bonsai plant in their own space using the phone's camera. Everything is just a tap away, whether it's chatting with our Zen AI chatbot, browsing the bonsai blog, or shopping for plants and accessories with seamless mobile navigation. Here is a high-level overview of our architecture. It all starts when we push code to GitHub, which triggers our GitHub Actions workflows. These workflows build Docker images for both the front end and back end, then push them to Docker Hub. At the same time, our infrastructure code uses Terraform to provision AWS resources like EKS, RDS, and S3. Before deploying to the cloud, we test everything locally using Minikube. Once verified, the Docker images are deployed to AWS EKS, where Kubernetes orchestrates the pods. The backend connects to a PostgreSQL database hosted on RDS, with secrets securely injected using AWS tools. We monitor the entire system with CloudWatch and use Lambda to automate daily database backups. This end-to-end setup lets us ship code quickly, safely, and reliably from local development to full production. CI/CD is a core practice within DevOps. CI stands for continuous integration, where we write, test, and build code, while CD stands for continuous deployment, where we release, monitor, and operate it in production. It's all about automation and feedback. We start by planning tasks and writing code. Our team used GitHub projects to organize everything and keep track of progress. Once code is pushed, our GitHub Actions workflows kick in. They build Docker images and run automated tests to catch any issues present in the code. If the tests pass, we release the app. Updated containers are deployed to AWS EKS with no downtime and no manual steps. Once the application is deployed, we shift into the operate phase, ensuring it runs smoothly in production. This includes managing, scaling, and logging and system health. We use Kubernetes to handle container orchestration, auto-scaling, and load balancing, while CloudWatch helps us monitor things like CPU usage and errors in real time. Automated alerts notify us immediately if anything goes wrong, allowing for fast response and minimal downtime. DevOps is a loop. It never stops. Every change goes through this cycle, helping us deliver high-quality features again and again. This is the full tool chain that powered our BONSAI app from start to finish. We collaborated using Slack, Zoom, and GitHub projects and Figma to plan features, assign tasks, and stay aligned as a team. For development, we used a modern stack of React for the front end, Django for the back end, and Chakra UI for component styling. Everything was containerized and tested using Docker, PyTest, and GitHub Actions. We developed and tested locally with Minikube, then used Terraform to provision infrastructure and deploy our application to AWS EKS. In production, GUnicorn served our Django backend, while Nginx acted as a reverse proxy. For observability, we leverage CloudWatch and EventBridge to monitor logs, trigger alerts, and keep our system healthy and reliable. I'll now hand it over to Aisha, who'll talk about Docker.
Thank you, Mikhail. Now let me talk about Docker. That was the core of a development workflow. It let us containerize the front end, back end, and database, so everything ran the same on every machine. Using a single Docker compose.yaml file, we launched our entire stack: React front end, Django API, and PostgreSQL database with just one command. By defining environments in Docker files, we avoid the work on my machine problem. We use multi-stage builds, for example, compiling the React app in a Node.js container and then moving just the final static files into a lightweight Nginx image for production. Docker volumes help persist a database and support live reloads during development. Internal networks let services talk to each other, just like they would Kubernetes. This made local development fast, predictable, and easy to scale up later. This illustration shows how we use a Docker and Docker Compose to run an application locally. On the left, we have a Docker Compose.yaml file. This is where we define all the service in your app, the front end, back end, and database. Docker Compose reads this file and builds each service using the corresponding Docker file. Once the images are built, Docker runs them as separate containers, one for the React front end, one for the Django API, and one for the PostgreSQL database. We also define volumes to persist data and enable live development changes, and we set up a shared Docker network so all the containers can communicate with each other securely. This setup gives us a clean, consistent local environment that mirrors production, perfect for testing and debugging before we deploy. In this diagram, we show how we run the full BONSAI app locally using Docker Compose. The app has three parts, and each one is inside its own Docker container, but works together as one system. A database runs in a container and uses a volume called Postgres data to keep data safe even if the container restarts or stops. The Django backend waits for the database to be ready, applies migration, and then serves both the admin panel and the API. It also uses volumes to store static files and media uploads. The front end is built with React and served through Nginx. It handles UI and sends API calls to the backend. All containers are connected through a shared Docker network called App Network. This allows servers to communicate securely without exposing unnecessary ports to the host. With one command, Docker compose up, we got a working full stack app locally. It's clean, easy to test, and a great step before deploying to Kubernetes. Now let's talk about Minikube and Kubernetes. Minikube gave us a local Kubernetes cluster to test the full app, front end, back end, and database without using AWS. We deployed the entire stack and verified how pods, servers, and volumes work together, making sure everything was ready for EKS. Since Minikube doesn't have a built-in load balancer, we use a port forwarding to open the app locally. We test storage by using persistent volumes, which help validate media uploads and static file handling. This setup mirrored a real Kubernetes environment, helping us test safely before deploying to the clouds. This diagram shows how we run a full-stack BONSAI app locally using Minikube. On the left, our local machine connects to the cluster using port forwarding. Inside the cluster, we have three main services: front-end, back-end, and database. Each service was created as a Kubernetes deployment, and they each have pods and a service that handle traffic inside the cluster. The front end is a React app served through Nginx. The backend is Django, which connects to a Postgres database. We also mounted persistent volumes to handle the media files, static content, and database storage, just like in production. Everything is organized inside a BONSAI namespace to mirror our AWS setup and keep things clean and modular. Now I'm going to hand over to Demand.
Okay, thank you, Aisa. Hello, my name is Damon, and I will review our CI/CD pipeline for the BONSAI application. We use GitHub Actions to automate everything from our code pushes to the testing and deployment of our application. This saved time and reduced human error. Each portion of our project, backend, frontend, as well as the infrastructure, had its own YAML workflow file, making the process of version control easy and repeatable. We connected GitHub Actions to Terraform, so changes to our infrastructure files automatically updated AWS resources like EKS, RDS, and S3. Our pipeline builds Docker images, tags, scans, and then pushes them to Docker Hub. Finally, they are deployed to Kubernetes. All of this is done in separate stages. All sensitive credentials like AWS access keys and database passwords were stored securely in GitHub secrets and Kubernetes secrets and were never hard-coded. This diagram shows our full CI/CD pipeline, and all of this was managed in one GitHub repo. We have 4 GitHub Actions workflows: front-end, back-end, infrastructure, and deployment. When code is pushed to the repository, the front-end and back-end workflows run tests, build Docker images, tag them, and push the images to Docker Hub. If we merge infrastructure changes, a Terraform workflows runs to update our AWS resources. This includes EKS, IAM roles, RDS, and S3. Once this pipeline has succeeded, our deployment workflow applies the latest images to our EKS cluster using kubectl apply command. All secrets like AWS access keys and Docker Hub tokens are secretly injected at runtime. Altogether, this setup lets us deploy both the application and infrastructure changes quickly, safely, and automatically. Now I'll discuss the Terraform portion of our CI/CD. We use Terraform to define and deploy all of our AWS infrastructure things like EKS, RDS, S3, and IAM roles. Instead of clicking around the AWS console, we wrote everything in Terraform files. Terraform handles the provisioning of our AWS resources automatically, making it reliable and reusable. Our infrastructure also tracks what's been deployed using a state file, which we stored in S3 with a DynamoDB lock to prevent conflicts when working as a team. Our setup is modular and reusable. We use variables to make the same code work across dev, test, and production environments. Terraform is integrated into our CI/CD pipeline, so any changes we push to our infrastructure code automatically runs the plan and applies them through GitHub Actions workflows. Now I will discuss the EKS portion of our CI/CD pipeline. To deploy our BONSAI application in the cloud, we use AWS EKS, a managed Kubernetes service that handles most of the heavy lifting for us. We provision EKS cluster, IAM roles, RDS for the PostgreSQL database using Terraform. Our frontend and backend run inside Kubernetes pods, and we expose them securely using an AWS load balancer and ingress controller. Everything runs inside a dedicated namespace for the BONSAI project, and we added role-based access control to keep things secure. Finally, we added auto-scaling for both the front-end and back-end pods so the app can handle more traffic when needed and scale down when things are not as quiet. This diagram shows how we deployed our BONSAI application to AWS using Kubernetes on EKS. So, how does it work? Well, the user's traffic hits the AWS load balancer, which routes it to our Kubernetes ingress controller. From there, traffic is sent to the front end or back end pods inside the BONSAI namespace. We use secrets and config maps to securely inject environment variables like database credentials. The backend connects to a managed Postgres database on AWS RDS media using EBS volumes. Horizontal pod autoscalers automatically scale our pods based on CPU usage. All of this is provisioned with Terraform and deployed using GitHub Actions workflows, giving us a secure, scalable, and fully automated. Now I will pass it over to Mikhail.
To keep our app reliable, we added monitoring and automated backups. We use AWS CloudWatch to track key metrics like CPU usage and set up alarms to alert us if something spiked. When those alarms were triggered, AWS SNS would send us real-time email alerts. We also built a custom Lambda function written in Python that takes daily RDS database backups. This backup system runs on a schedule using EventBridge and notifies us by email whether the job succeeded or failed. Together, this gave us the peace of mind that everything was being monitored and backed up without manual work. One of the toughest parts of working with AWS EKS was getting IAM permissions configured correctly. It forced us to slow down, dig into the AWS documentation, and truly understand how IAM roles interact with both EKS and Terraform. We also ran into tricky ingress issues with Minikube running on WSL, which led us to use port forwarding. Another critical takeaway was the power of documentation. Clear, consistent documentation helped us keep aligned as a team and collaborate effectively, especially when juggling multiple tools and environments. And of course, the biggest lesson of them all, we didn't just operate as a team, we operated as a family. Whenever someone was stuck, someone else jumped in, we communicated, supported each other, and grew stronger together, just like Dom would have wanted. We covered a lot, from planning and coding to automating builds, deploying with Kubernetes, and monitoring with AWS. But this journey wasn't just about tools or infrastructure. It was about learning how to collaborate, adapt, and build something meaningful as a team. We're incredibly proud of what we achieved, and even more grateful for the support we got. A huge thank you to our instructors for guiding us through the DevOps course, and to the entire Platoon team for creating an environment where we could grow, experiment, and thrive. We're excited for where these skills will take us next. If you have any questions, we'll be glad to answer them now. Thanks again.